Hey everybody, this is going to be your first day of variables and expressions. So this is day one, this is your first video. Alright, to start us off, a variable is going to be usually a letter that represents the value of an unknown quantity. So we see this typically as X, Y, or Z. Could be any letter really in the alphabet. Okay, operation symbols are going to be simply multiplication, division, addition, and subtraction. So these are your operation symbols. An expression is going to be a mathematical phrase that includes variables and or numbers, okay, and an operation symbol, okay, but it does not have an equal sign. So that's your key right there, is that it does not have an equal sign. So an expression has no equal sign. All right, so with what we're going to do with these expressions, we need to know some keywords. So if we take a look at this chart, here are some keywords when we're talking about addition. Here's going to be some keywords when we talk about subtraction, multiplication, and finally division. Some ones that you're going to see quite frequently are sum, total, difference, or less than. For multiplication, you'll see things like times and product a lot, and for division, you'll see quotient a lot. Okay? So just keep this chart in mind. This might be a good slide to pause on, kind of take a quick look at it, and really understand this chart. Okay, so let's actually do some examples here. What we want to do is take algebraic expressions. Remember, expressions have no equal sign, and we want to write them into, and we want to write the expression from the words. Okay, so we're given the words here, 4 more than P, and we want to put an operation symbol in there. Well, more than, okay, if we look back at our chart, that's actually not on there, but more than is going to be addition. So really, if we say 4 more than P, we're really saying P plus 4. And we just wrote the algebraic expression for the word phrase 4 more than P. Okay, Y minus 12, okay, so that's going to be subtraction. So Y minus 12 is how we'd write that out. Quotient for number 11 here is division, remember? So we're going to take the quotient of n and 8. Or we can write this as n divided by 8. Either one of those works. Okay. The product of 15 and C, remember that's going to be multiplication. So we're just going to say 15C or 15 times C. Usually we use a little dot for multiplication. Okay. Number 13, a number T divided by 82. Or we can write this as T over 82. Okay, not 82 divided by T. That is not the same thing. The sum of 13 and twice a number H. So this one gets a little bit trickier because there's going to be 2 operations in here. Well, sum means addition, and twice a number is going to be like we're using multiplication. Okay, well, twice a number means we're going to times it by 2. So we want the sum of 13, so 13 plus something. 13 and twice a number H, so 2 times H. Okay, this one is very, very similar, so 6.7 more than, so plus the product of 5 and n. So we're going to multiply 5 and n because product means to multiply. So 6.7 more than 5 times n. And you could flip this around to say 5n plus 6.7. That one is the same thing. Okay, and then finally the last one here, we have 9.85 less than the product of 37 and t. Okay, so less than the product of these guys. Okay, well, product, remember, means multiplication. Less than is subtraction. So first we're going to write the product of 37 and t. Oops. First we're going to write the product of 37 and t, and then we're going to subtract 9.85 from that. So 9.85 less than the 9.85 less than 37, the product of 37 and t. Okay, so that's how we write an algebraic expression from a word phrase. So, yep, you guessed it, we're going to go backwards now. So, we have q plus 5, okay? So, we could say this as, there's other ways you could write these, but I would say 5 more than q. Okay? 18, we could say, we have division here, so we could say the quotient of q and, it'd be y, of y and 5. You always list the one that's on the top of the fraction first. Okay? For the next one, we'd have product, so the product of 12 and x. Okay. Next one we're going to look at, we'd have the product, or the sum, because it's addition, so the sum of 49 and m. Here are ones where we're going to have double operation ones. So if we look at number 21 here, we're going to have 9 times n, so 9 times n plus 1. We could also say this as 1 more than the product of 9 and n, all sorts of things you could do there. Okay, and then we're just going to do number 22, so the quotient, because we're dividing here, z and 8, so the quotient of z and 8 minus 9. Or we could say 9 less than the quotient of z and 8. Okay, and we'll skip those two. All right, so what does this actually all mean? Why do we need to know this? All right, well, let's say you're on vacation and you rent a bicycle. You pay $9 for each hour you use it, and it costs $5 to rent a helmet while you use the bicycle. Okay, we want to write an algebraic expression to basically model the situation so we can figure out how much we're going to pay. Okay, so $9 per hour, okay, would give me 9 times h, because $9 times, we do $9 times the number of hours that we rent it for, and it costs actually $5 if we look up here to actually rent the helmet. So that's no matter what. So we have to say plus $5 no matter what. So this would be our algebraic expression to model the situation. Okay. For your homework, I would like you to write me 3 to 5 sentences telling me something about yourself, since this is your first video. And in addition to that, if you go back to my website, you should have noticed a form next to the video. Please click on that and take that 3 little question survey. Have a good day. We'll see you tomorrow.